Hello and welcome to another episode of LeetCode. Today is an editorial for weekly contest, 221st weekly contest. Let me pull the demonstration. All right. So, yeah, I believe we can actually start a virtual contest. It will be easier this way. So let's go. Okay, let's open all the problems immediately. This way we don't need to worry about it later. Okay, first problem is as follows. Determine if string halves are alike. Okay, so we are given a string of even lengths. We want to split it into two halves of equal lengths. Okay, and two strings, so two halves in our case, are alike if they have the same number of vowels. And yeah, so our strings can have both uppercase and lowercase vowels. I'm not a big fan of uppercase letters, but whatever. Yeah. Okay. Okay. Are we in the correct account? Okay, whatever. So we have a string. Okay, let's convert it to reference immediately. We can take first half and second half. For this we need lengths. So string length. First half will be string, substring from 0 to length over 2, and we can divide by 2 via bitwise shift to the right. And we also want second half will be string, substring from length over 2 and length over. I believe it is not necessary to write second argument. So first argument in substr is starting position and the second is length. But if you omit the second argument, then it goes all the way to the end. So we should be fine with this. And I believe we can define a helper function. So count vowels. This way we won't have to count vowels twice. I mean, we will call this function 2 times, first from the first half, second from the second half, obviously, and return the result of the comparison, as simple as it gets. So, so far, there were no ideas in this problem, simple implementation, just only tip I can give about simple implementation problems is to write code fast, do not talk like I do, right? Because I obviously spend a lot of time. Okay, so int vowel count get 0. Also, don't use that long variable names. I'm using them because this is an editorial, right? I want you to understand solutions, so we will be using meaningful names. And for auto letter in string, if okay. Let me cast the character to lower, so we don't have to worry about uppercase. I believe in Python you can immediately cast the entire string to lowercase. In C++, I'm not sure that it is possible. I mean, without some calls like, yeah, I mean, there is no simple method in a string that does exactly this. So if letter equals a, or I believe there are faster ways to check against walls, but I'm not sure how to do it. I mean, in Python, we could write something like if letter in, and then write a string containing all vowels, right? But I'm not sure how to do it significantly, in a significantly smaller amount of code. Okay, so we got our answers, true, false, false, true. It appears to me that this answer agree with sample test cases. Let's go. Okay. So first problem is accepted, simple implementation, nothing particularly smart. Let's head on to the second problem. Maximum number of eaten apples. There is a special kind of apple tree that grows apples every day for n days. Okay. On the ith day, the tree grows apples that will rot. Okay. After days I days. That's it on day I plus days I. Okay, okay. So some apples grow, and then, yeah, it is possible that apples don't grow. Okay. We can eat at most one apple a day. I'm not sure why we can eat at most one, right? I mean, I'm a big fan of apples. Could eat something like 5 a day, but whatever. Yeah, you can keep eating after first 10 days. Okay. So the problem is why we cannot eat all the apples, because they rot, right? So become impossible to eat after some amount of time. And we are interested in eating maximum number of apples. Well, this kind of problem clearly operates with some kinds of events which are related to time. And now the way to process such events is typically by using priority queue. We will insert events of type. So events of two types come to us. Like first type is that some apples grow, right? This is simple. Now, the second event is that some apples rot on some day in the future. These future events we will insert into priority queue. Priority queue will be sorted with priority equal to day, right? So we will process the events in the correct order, right? Yeah, let me write it in C++. Okay, okay. So I will immediately create priority queue. I believe we want to store pairs. That's it, day and some information about it. So how do we name it? Events. Okay, events. We will also need some sort of answer. So that's it. Eaten apples equals 0 initially. And then at the very end, we will return eaten apples. And in between, we should do the following. So we can grab ourselves a length, right? For example, apples size Yeah. Day count. Let us use meaningful names. So now we iterate over all the days, and we add an event to priority queue. So in place, and we use in place because priority queue contains pairs, and I don't want to construct pair myself. I want in place to take care of that for me. In places are very useful. They save memory so that you don't need extra copies. You construct the pair in place. So first, priority queue will determine where it should construct the pair, and then it will construct it there. It's very convenient. Okay, so we want to construct what? Day plus days day and apples day. So what I'm doing is the following. I say that a total of apples day, apples, came to us, and then they will expire, that's it, rod, right? On day plus on the current day plus days a day. So exactly as stated here. Excuse me. Okay. So, and I believe there's nothing bad if we add a 0, 0 event. Okay, well, let's keep it simple. Now, what we want to do is, obviously, we want to eat apples greedily. It makes no sense to eat apples which will expire later on, right? Because if today you eat apple which expires 2 days after today, and don't eat apple that expires tomorrow, and you miss tomorrow's apple, right? So we always want to eat the apple that is closest to being rotten, I believe. Yeah, rotten. Okay. Not exactly sure whether or not we should add -1 here. Okay, let's keep going. While our events queue is not empty, we want to take the top. I believe priority queue has a method named top and not something like first or whatever. We can check it later. So we take top, or is it front? No, let me check. Priority queue, all right. So we have what? Right, top, pop, push in place. Okay. So we take the top event, and now if event first is smaller or equal than day, so than the current day, then it means that these apples have expired and we got to pop them. Else, we can eat one apple. So, oh, okay. Or if event second is equal to 0. So if we have already eaten all apples, or if these apples have expired. Then we ignore this event and go to another iteration. Otherwise, we can eat one apple, so we increase the counter of eaten apples. And I believe we can decrement the number of apples, right? Because we eaten one apple that expires from that event. Then we should break. So yeah. Because we have already eaten one apple, we should proceed to the next day. After this happens, we know that every days, right? So apples, they don't last very long. At most to what, 20,000 days they will expire. So we can just keep doing the same thing, right? Starting from day count and I think that this is not the best way to do it, but this time we don't have anything to in place, so we just process events, right? So eventually events will end, and we can kind of speed this up if we add it here, right? So we loop until we have events to process. Yeah. Yeah, this is the correct condition to stop. Looks much nicer. I hope that when I take top by reference, I'm able to decrement second. Let's see if I'm right. Whoa. Okay, so priority queue does not allow modifying its elements, or top returns not reference. Okay, not a big deal, not a big deal. We can, what this means is that we should pop this event anyways, right? And insert a new event. So event first, event second -1. Yeah, because we somehow cannot modify we cannot obtain the reference to the element from priority queue. And this is reasonable because if you try to change the key, so the priority, right, then the structure of priority queue should change. So that's maybe why they don't want to allow us to change elements. So that's why we take pair out of the queue anyways and in place it back if it's valid. And I believe we can simplify these conditions. So we pop anyway, but we only use this apple, right? If it has not expired yet, so the expiration day is greater than the current day, and there are some apples in it, right? Because when we eat apples, they may end in one of the events, and it makes no sense to process, to eat apples from such events where there are no apples. Should work. Okay, let's try. I mean, the answers on sample test cases are correct. Okay, not a big deal. We can fix it. I would like to know when exactly we eat apples. Let me print the current event here and here, and probably I want current day as well. Yeah, most probably I also want each event on its own line. And before returning, I want to print another new line, so to separate cases one from another. Okay, so in the first case, what happens? On the first day, we have apples that expire on the third day. And we have one such apple, then we eat it, obviously. Then we get two apples that expire on the third day, and we eat one of them. Then we get three more apples that expire on the first day, and we eat one of them. Then on day 3, all of these apples have expired. And then we, one by one, eat apples that grown on the fourth day. So it seems legit so far to me. And we also eat on day 7, because these apples expire on day 7. So we correctly process what happens after the end, right? After the end of our first day count days. Here we got what? 3 apples that expire on day 3, we eat them. And we get 2 apples on day 5, and we eat them on days 5 and 6. No, we get, yes, okay. Now this is interesting. So we get 9 apples that expire on day 3. Oh, I'm stupid, because priority queue provides access to the maximum elements. Right? Am I right? By default, I mean. And we want to the minimum element. I always forget. By default, largest element, right? And we want, I believe, yeah. That's exactly what we want. So std vector is a container, in which the elements of the queue will be stored. And std greater means that we want smallest element. Of course, we also want pairs to be there, and I'm going to use some simple trick. So I don't want to write pair all the time. So I'm going to declare a type event and just use it. It's very useful in C++. Okay, 7531 now. Everything seems fine. Let me comment unnecessary output. I believe it doesn't matter if you do or if you don't. Okay, so we got accepted. So the problem was that by default, STT priority queue provides access to the largest element, and we want it to the smallest because we want to process the apple that will expire on the smallest possible time that sits closest to the current time in the future. So yeah, from this problem, you should remember for future that processing events that have to deal with time is all about priority queues. Priority queues are very good in processing events in chronological order. I believe that's it. Yeah. Yeah, that's it. Let's head on to the next problem. Where will the ball fall? We given a grid and balls fall. Okay. Okay, so every cell is dissected by diagonal. Diagonals go either from the left to the right or from the right to the left. And the balls follow the path. Okay. So far, pretty reasonable. What do we want to return? We want to return column that ball falls, or -1 if it gets stuck. Okay. I believe this is going to be simple implementation problem. We just want a nice way to process it. So we are going for every ball just maintain track of where it falls. Let me immediately create vector int answer, then return it. I also want int row count, column count. Row count will be grid size. Column count will be a grid 0 size. And the answer will be of size column count. And what we can do is for every ball, that's it for int ball equals 0, ball less than column count plus ball. And the reason why I say this is simple implementation because constraints are very small. You have just to follow the path of every ball, and yeah, and you'll be fine. Initially, we have row, which is 0. This is the current row of the ball. And we also know that initially the ball is at the top half of the cell, right? So top equals true. We also want an ordered map, which will define how our balls fall. So we have a current state. A current state will be a Boolean variable, so top or bottom half of the current cell. And we also want to know another Boolean, which will correspond to whether the diagonal is to the right or to the left. Based on these two, we can determine which way the ball falls, right? So if the ball is here and the diagonal is such, then we get what? We get plus plus column, and row stays the same. So it falls into this part, right? or does it? Okay, we also have to deal with cases like that. Okay, we will deal with them later. Now, another option is when the ball is bottom and the diagonal is like that, then it, this ball effectively goes here. You can say like balls move like this, okay? So plus plus column. And we can define such cases just by doing it, well, after two operations, a row should increase. If it doesn't, then our ball got stuck. So if we are in position like this, then ball falls down, so plus plus row. If the diagonals are like that, here ball goes to minus minus column, and here again plus plus row. So I will have a map which contains all of this information. So it maps from a pair of Boolean values to to another pair of Boolean values with no. I mean, I should definitely have a smarter way of doing this. Okay, let's go with pair of integers, which will denote the difference in row and column, which we have to apply. So moves gets the following. So a lot of pairs. So if our diagonal is to the diagonals, okay, diagonals are again integers. So okay, so we have true, which means that we are in the top half, and -1, which means that diagonal is what? -1 from top. Okay, -1 are these diagonals. And top and -1 corresponds to -1 column and 0 row. I will, let's make a row first. This is the first entry. Yeah, what else? So true and 1 corresponds to top half, but the diagonal goes to the right. So in this case, we increment the column and don't change the row. So row gets 0 and column gets +1. In other cases, we increment row and don't change the column. We can, of course, I know what you're gonna say, we can do this thing with plain if statements, but I'm a big fan of unordered maps for such purposes, because it becomes like you only have to think about what goes on with movements only once when you define the unordered map, and then you can use it all the time. Okay, so initial state is we are at the top half and in row 0. Then we can be very silly and just don't detect the repeated states explicitly and just simulate for row of 2 times row of moves, right? Out for int move equals 0, move less than 2 times row count. So if the ball makes it to the end, it will do it in exactly 2 times rows -1 moves. And it will obey Oh, actually, you know what? Yeah, we need also column which gets ball. Right. Oh, we also wanted to keep track of top. Well, that's simple. Or is it? Yeah, I got to really think about it. So we make a couple of moves and then we just need to explicitly see what goes on with moves. All right. So let me check. I want diagonal gets grid row column to know what is the current type of the diagonal here. Okay, we know the diagonal. We know whether we are in the top half or the bottom half. So we can use our unordered map already, and we will get yeah, let me say move index. So the move which is we are going to do is obtained as moves and std make pair top and diagonal. Right, so we take our pair of whether we are in the top half or the bottom, what is the state of the diagonal, and our unordered map gives us the answer, how many rows and columns we should move. Okay. Okay. Now we have to process this move. So row plus equals move first, column plus equals move second. Remember that values in our unordered map are changes in the row number and the column number. Okay, so now we know in which cell we ended up. So if we were in the bottom half, right? So if not top, then top, and we always fall down. We cannot get stuck when we fall down. Right? We can only go stuck when we go to the side. So when we are in the bottom half, we always get to the top half. When we are, however, in the bottom half, then we want the diagonal. Is it guaranteed that balls don't fall out to the side or not? Is it guaranteed? I don't understand. Can we have a situation like when the first ball starts here and it goes to the side? Yes, it can get stuck, so, okay. It's not a complicated case, so. If if column becomes greater than column count, and I should really say greater or equal, or column becomes less than 0, then we got stuck. We can break and stop the process, right? We can also immediately assign answer at ball gets -1. Else, I know it's not necessary because we break anyway, but whatever. Again, I like when every statement that is semantically else branch of the if-else statement is the else branch of the if-else statement. So we want to check whether or not the diagonal to the in our next cell. So it, yeah, not that fast. I agree with you. Int new row and int column, right? Because we don't want to forget just yet the previous row and column. If diagonal row column equals diagonal new row new column, that means that we have a shape like two diagonals going to the same side like this and this. Then we are fine. We go here. We transition to the bottom half. If, however, we have a shape like this, so diagonals are different, then we get stuck. Let's write exactly that. So if diagonals are the same, then we get to the bottom half, else we get stuck. And actually, yeah, we can initialize with -1 so that we don't have to write it explicitly. And then we break again. And also we can flatten this else if tree like that. Okay. Okay. Otherwise, if we survive all the moves, then we can set answer at ball to the current column, I believe. Let's try. Huh? Right. Unordered map and the STD pair are not close friends. We need a struct pair hasher. I believe it has one operator, which is like that. I'm gonna make it template because I don't want to care to define, I mean, separate version for everything. So first type, second type, pair of first type and second type, pair, and yeah, I think we can also make it like this. Turn std hash from the first type of pair first in, no, not like that. Most probably hash. I also believe that you have to construct it and then call std hash of type 2 construct call from second and shift 1 to the right. I believe this is a standard implementation of pair hasher. We can pass it here. And now we can run. Can we? No, we still can't. Okay. Okay, this is actually not a big deal, right? Oh, I also forgot to gets new row, column gets new column. And we want to write it here and here. Let's go. Diagonals, grid, because this variable is called grid. Against the left wall. What? Oh, okay, because it is possible that we process everything. Okay. Okay, so we will create another variable which is called broke. It is initially false, and when we break, we set it to false, to true. right? So that we know how the loop ended, whether it ended in a broke or not. If not broke, then and only then we want to change the answer. Minus one, I believe there are too many ones here. It should not be that many. I mean, we can obviously follow the movement of the ball. Let me do exactly that. What I'm going to do is output current row, current column, and what else, top, and also top. Yeah, and I want each such move on a separate line, and I also want to separate balls from each other, right? And I also want to separate test cases. So first ball falls as follows. It's initially in the, it's really not very good. Yeah, whatever. I just want to. Okay, much better. So let's, can you see, can you? Yeah, you definitely can see the screen. So let's follow the movement of the first ball. It's initially at 0, 0 and in the upper half because 1 is true. It means that we are in the upper half, and gets 0, 1 lower half, 1, 0. No. It should get to 1, 1. Okay, so we already know our mistake. Sort of. Column changed not in the way expected. When we all right, because yes, because new values are not the movements, but the current state plus the movement. Let's go again. The answers are correct. Let me come, for sample test cases, of course. Let me comment on necessary output, just to make sure, right? Yeah, the answer is the same. Let me submit. Okay, accepted. So the problem was that new row, of course, should get current row plus change in row, not the plain change, okay? So again, simple implementation. You just need to consider cases separately. So the best scenario would be if you consider the state of two cells, so the current cell and the next cell. Based on the current cell, you can know to which cell you go, and based on the state of the diagonal in the second cell, you can say whether or not you get stuck. Of course, this part can be written in if statements. Okay, here you can define move via some if statements, but I don't want to do it. I allow using unordered maps for such a reason. Yeah, and the only thing you have to keep in mind about unordered maps is that they don't work with pairs by default, but you can easily define pair hasher. And there's also a trick that allows defining a tuple hasher, I believe. So you don't need to define tuple hasher like for every number of arguments. You can use already templates, I believe, and define a tuple hasher in general. I really should post the corresponding code, I believe, because yeah, it's a great trick. I definitely want to see it. Okay, the final problem is maximum XOR with an element from arrays. We're given nums, which consist of non-negative integers. We also given queries. Queries want us to find maximum bitwise XOR of the given value with all elements of nums, but elements of nums should not exceed the given maximum value mi. Yeah, whatever. Yeah. Okay, so this problem contains several techniques. First of all, maximizing bitwise XOR with an array definitely means that you need some sort of trie, right? So let me define class trie straight away. It will have several methods. Let me define, well, do I want a constructor? No, I don't. No, I don't. Yeah, you're right. So I want try not. Try not will have, yeah, it's more convenient to implement try, why not? Okay. Try not pointer left child, pointer right child. And again, we already seen, no, we haven't seen that. So yeah, I prefer this way of defining things. And we will want a root, right? Right. Okay, we can define it once per test case. So eventually these was null pointers. Okay. Now we want two functions that operate with try. So insert try node root int value. So we're going to insert integers into try, bitwise try. So how does it operate? Let me draw something. Also, how much time do we have left? Just interested. Hello? Okay, so we have plenty of time left. How does it operate? So suppose we have numbers like this, and we want to build a trie. So we write every number in binary, and if necessary, we pad with leading zeros so that all numbers are of the same length, right? So these are our numbers, 0, 1, 2, 3, 4. Then we create a root. It has two children, 0 and 1. Now, in the one branch, we have only 0, 0. So this leaf corresponds to 4. And here we have a complete tree, complete binary tree. So here we get 3, here we get 2, here we get 1, here we get 0. That's it. So the only difference that our nums can be huge. So we will start not here, but we will treat all numbers as if they are 32 digits long, regardless. Yeah, we can pad with more zeros. The only concern is to have all numbers of the same length. And all integers in C++ fit into 32 bits. So that's what we're going to do. So we want int value, and we also want int digits. Initially, it equals 32, and it does the following. We need what? We need most significant bit of value. Whoa. No, we want digits. Okay. So we want to access the digits bits from the right. How do we do it? We take value and 1 shifted digits minus 1 to the right. For that purpose, I'm going to, so this is the exponent of 2, the current power of 2, for which we consider the digit. So for example, for 4, 32nd from the right digit is obviously 0, then we have a couple of zeros, and we have 1, 0, 1, 0, right? So if like this, then we create a right child. Yeah, I believe that the common practice is to have left right without child, so let's stick to the common practice. So it gets new try node. Okay, whatever. And we want to call insert recursively from value and digits -1. Root right. And also if digits less than 0, then we do nothing. Okay. So current digit is 1 here, and current digit is 0 in this branch. Then we create a left child. Yeah, you're right. A lot of typos today. I don't know what's wrong with me. Okay, so otherwise we create a left. Okay, but it is possible that we have left child already. So if we only need to create a new leaf, a new child, if there is no one, there is no such child. So let me add this simple if guards here. All right. So if there's no left child, but we really want to go there, then we go there, we create one, right? And then go there. Okay. Also, we want insert will return nothing. We also want max XOR query from try node root int value, also in digits equals 31 actually. So all right. We will also need some sort of output or result, I should say. So initially, maximum XOR is 0. It's okay. And we check if okay, so if or do we need result? No, we don't. No, we don't, because we will return integer. Okay. If digit less than 0, then we return 0, just in case. So if otherwise we want to go to the opposite branch. So we again check what is the current digit. So in this case, the current digit is 1, and to maximize, so we obviously want to go to the 0, so that's it to the left child. If root left, if there is a left child, then we return, and we can, we are guaranteed that the current digit of the result can be made 1. If we go to the left, then we will need to return max XOR from root left value digits -1. Otherwise, the current digit of the result will be 0 because it is impossible to make it 1. And we will need to go to the right branch. Okay. And I know you don't necessarily need, so, okay. If there is a right node, then we go to the right node. If there is no right node, then we have to return -1 because we have not found the corresponding value. Now we just copy this, right? And change root left and root right. So if the current digit is 0, then we want to go to the right. So we want to go to the branch where the current digit of the element of the array is 1, because then XOR of these digits will be 1. And we, of course, we want to maximize the current digit of the result greedily. So we start from most important digits because we shift the most to the left. Yeah. Yes, okay. What we want now is we have insertions and we have queries, and we want to process queries in some order. And obviously we want to process them in the increasing order of MI param, right? So we are going to insert values into trie one by one. We don't want to make queries const because we are going to sort them immediately. We want, yes, okay. So we want to sort nums. And we want to sort queries. We want to sort queries, but we want to sort queries by second param. So let me create a quick lambda. Which will return a Boolean value, of course, corresponding to first one being smaller than second one. And I want this to be a complete order, so I will need to make pair of first. So we first compare second element, that's its bounds, and then we compare first elements. Just like that. What are we going to do next? Let me think. We want to create a trie node root. Trie int num index. Okay, I'm going to be as fast as possible. Or am I? No, I'm not going to do that. We have two indices, number index and query index. And I believe I really should have added query indexes before sorting. All right. So because we are going to process queries in the wrong order, we really need to add the original indices. So that's it. Queries will become tuples of 3 integers. And for every, yes, and this means actually that we can make queries constant. For const auto query in queries, we want to in-place back into indexed queries the following query. Okay, so first we want query first, and we want query at 0, then we want query's index size. So the current index is 10 like this. Okay, then we can sort queries indexed without lambda. Very good. Yeah, so I changed queries index to contain first mi, then xi, then I. And I also want to create a vector of answers of the size num size. Or do I actually? No, of the query size, of course. Right. So then we do the following. We iterate through queries, through indexed queries. Okay. So while nums at num index is smaller than query 0, so the current number in the numbers is smaller than 1, then we can insert it into try, right? So insert root nums num index and increment nums index. We will also have to compare if nums index is smaller than nums size, and we need to cast num size to integer. This is a very bad way to do it, and I hope I will have time to explain later why, but let's keep it this way. So while we insert integers, then we have to process query. So answer at query second. So the second element of the query now contains the index in the original array of queries. We want to assign answer here, and we want to query our root. Notice that I don't have to write digits because it has a default value. So I want to query for max XOR with the first element of our query, and then I will be able to return answer. I believe this won't compile, but let's figure out why. Okay, so does not provide a subscript operator. I'm stupid. Never mind. Let's not use tuples, let's use vectors. Can we do it like that? No, we can't. Maybe we can push back like that. Then a vector will be initialized from 3 elements. Oh, we still can't. Because size should be casted to integer. Okay. Because I mistyped. We are getting there. I mean, Okay. I mean, only 2 lines remain to fail due to compile error. 337, 15 minus 1, 4. Very bad. Should be 5. We are okay. Max MI, yeah, does not exceed. So I messed up here. I previously wrote like this, but we are okay if they are equal. Hello, hello, hello. Any second now. Any minute now. Unknown error. Wonderful. Okay, 337, 15 minus 1, 5. Let's go. It agrees with these answers. Accepted. Okay. Whew. A lot of explanations, so we are not particularly great. We are 97, and we had one bug, so we can drop down a little bit. Yeah, very slow, but again, we were explaining everything, so I guess it would be a little bit faster. But never mind, it's okay. It's okay. Wow, people are great. Really awesome. Okay. I believe this wasn't a perfect explanation, so let me walk you through an example. All right, so what is going on in this problem? We want to process queries in the increasing order of MI because then we are able to not care about this condition. We simply insert all elements of nums in order when we need to into try, okay? So what do we do now? After queries get sorted, they are in fact actually already sorted by a second parameter. But we also append index just in case they don't get sorted. So our queries are like that. First is MI. Yeah, and I immediately write it wrong. So first is MI, then goes XI, then goes I, right? MI, XI, I. And we need I because we will sort all queries and the order can change, but we want to return answer in the original order. So then we have 3, 1, 2. Oh, actually, yes. Of course, indexes are 0-based. Here we have that. And finally, we have 6, 5, 2. Now, initially, our try is empty. So this is root of our try. And this query says, I'm okay with all elements that are at most 1. We go ahead and add 0 and 1 to our try. So our try now looks something like this. So this is 0, this is 1. Then it says, I want an element that gives max XOR with number 3. We say, okay, what is 3 in binary? 0, 1, 1. So initially, we would like to maximize XOR, right? What maximizes XOR? When all bits are different from that of value. So we would like to go here, here, and here. But this path does not exist. So we have to settle down for first 0. Okay, so we say, okay, we are unable to find a number that starts with 1 because of MI. So we go here. Then we want 2 zeros and we can obtain them because there is such paths. So we get the answer of 3, right? XOR of these two numbers is 3. So we get 3 and then we look at this index. It says that this query was first, in the initial array of queries, we go ahead into our answer array and we change first element to 3. Okay. Then we go to the second query. It says, I'm okay with all elements up to 3. We insert 2 more numbers, which result into try like that. So this is 3, this is 2. And then it says, I want element that gives max XOR with number 1. We write number 1 in binary. We think, okay, the max XOR would be 110. We think, can we go to 1? No, we cannot. We say, okay, let's head on to 0. So we admit that we cannot get 1 here. Go to 0, and we want 1, 0, and we can have it. So this number is present in the try, and it gives XOR of 0, 1, 1, which is again 3. We then again go to this index. It says, oh, I was query number 2 in the original array of queries. We go to the second element of the answer and again put 3. Right? Then we process the last query. It says, I'm okay with all numbers up to 6. We say, okay, let me insert 4 for you, which is 1, 0, 0. That's 4. And then it says, I want elements that gives max XOR with 5. Say, okay, 5 in binary is 101. Max XOR would be if we had element like that. And turns out that we can have it. We can have it. So we go 0, 1, 0, and we find that there is such element. And the XOR of these two numbers is 111 in binary, which is 7 in decimal. And we say, okay, now we want to add 7 to our answer. Where do we want to add it? We want to add it to set third element of the answer to 7. We go ahead and set it. Just like that, we return 337. I believe you can walk through the second example yourself if you want to. It's entirely the same. So a couple of useful ideas when you want to maximize some sort of binary operation, some XOR specifically, then try is your best friend. All right, check out the Explore course about try if you haven't already. It is great. Let me navigate the in a second now. So learn then more than try. Okay, I was solving this on my primary account, so here we don't have any progress, but whatever. But yeah, this is really helpful, okay? Especially practical applications. If you get a couple of problems here, you should definitely, yeah, whatever. You should definitely check this out if you haven't already. A couple of more problems here. Okay, so you know that try is your best friend in case you want to maximize XOR or do anything else with bits of integers, right? Also, an important idea is that sometimes processing queries in the sorted order will simplify the problem, because queries have some constraints that can be easily met when you process queries in sorted order and cannot be met if you process queries in random order. I would say that you can always sort queries, even if you don't need it, because it will never result in time limit exceeded, because queries lengths, like I have not seen personally problems where there are more than 1 million queries, and usually n log n complexity for 1 million will work. I mean, on Codeforces it will definitely work. On LeetCode problems have up to 100,000 queries. And it will definitely work. So even if you don't need it, so certain queries is a good practice, okay? It may help you, right? And also certain, like here, we don't care about the order of numbers, so we can sort them, right? Simple logic. If you don't care about the order, you can sort. If you care about the order, so you want to output answer in the exact, obviously, in the exact same sequence as original queries were, then you can always append current index of the query and then sort, so that you will always know where to put the answer to the queries, even if your queries got messed up. Okay, you always have index as the last element of your query. So yeah, I would say that's it for this contest. Pretty nice contest. And also, in case you're wondering, it would obviously not work if you didn't use try, but instead try to brute force. So check every query against every number, it gets 10 to the 10th, obviously won't work. So that's why we need try in the first place, because brute force doesn't work. But overall, it's a good practice to check if the brute force will pass the constraints. I don't mean that you have to write any code to check that, right? You can simply estimate the complexity. So quadratic complexity for 10 to the fifth won't pass, a general rule of thumb. I would say quadratic passes for 10 to the fourth. On LeetCode, probably to 3 times 10 to the fourth on Codeforces. But also not guaranteed, like 10 to the fourth is a reasonable upper limit. That's it. I believe I will prettify this code a little bit and post on GitHub in case you are interested in having try for yourself. This is a bad way to implement try, all right? A good way would be to create class try, make insert and max XOR methods of this class, and then do not operate obviously with pointers like that, because what the heck? What the heck? I mean, what the heck? Like, we have a couple of words new, but we don't have delete, right? What are we doing? What are we doing here? This is terrible. We should definitely write a destructor of try node. So if left and delete left, if right, delete right, and then at the end we shall delete root. I believe this should work. Let me check, because otherwise there are obviously memory leaks, and memory leaks are not great. I mean, they are terrible, so you should definitely not write like that on the intro. Yeah, now we delete everything, I believe. So we create one node explicitly here, then we delete it, and when node gets deleted, it deletes its children if it has any, right? Now it is bearable, but again, working with raw pointers is not a good practice in C++ anymore. You have smart pointers, which will sort of take care of themselves, but they're not as simple to operate with. That's why in a contest, we use raw pointers. But in case you're interested in writing good code in C++, you should definitely check out a unique pointer, right? Shape pair and stuff like that. And you also obviously want to encapsulate insert, max XOR, and probably other methods that you have with your try into a class. and then work with memory in the class, right? I believe that's it for today. I hope you enjoyed this kind of editorial. Let me check. Yeah, we are 101. Well, not great performance, let's put it this way. I mean, our intention was to solve all the problems first and explain all the solutions. We fulfilled our goals for today. Right. Yeah. I hope it helped you in case you were wondering what are the solutions to today's contest. I think I can release it immediately. So you don't have to wait until, I don't know, 6 p.m. Pacific Standard Time. I will just put the link in the comments to the contest. I'm not sure if it is. I mean, LeetCode approached me and said that I'm advertising my channel. I'm not sure why they think so, because I mean, I'm not making any money off it. It's just free content for you guys to improve. So yeah, I mean, they are not against having written editorials, but they are against videos on YouTube. Why? Do you understand? I don't understand. I mean, I'm literally sitting here in the LeetCode t-shirt advertising LeetCode for free, and they don't want it. I don't understand. I don't understand. Yeah, whatever. I believe that putting a link to editorial is not in any way an advertisement. I don't even make posts about it. Okay, I just comment on contest. Whatever. So hope you enjoyed. Hope it helped you, and see you next time.